Okay, so metals are extracted from the ores that are found in the Earth's crust, and the method used to extract the metals from the ore is linked directly to the reactivity series. Part of the reactivity series is shown below. So we've got a list of all the metals, with this being the most reactive, and then working our way down to gold being the least reactive. So the first question is, iron ore contains iron oxide. Iron can be extracted from the ore by heating it with carbon. So if we look at what's going on here, my iron oxide has oxygen with it, and after the reaction with carbon, it just becomes iron. What we've done there is we've removed the oxygen, and removal of oxygen is called reduction. So this reaction is a reduction reaction, so we could say the iron oxide is reduced, or we can look at it from the carbon's perspective, and the carbon has gone from here to here, so this has been oxygen added because it's now a dioxide, so this has been oxidized. Okay, so if we look on here, the one that matches this is the iron oxide is reduced. Next question, I've done the working out first, and I thought I'd take you through it. So we're using here Mr. Moles lives underneath the mass equation. And what they don't give you, and this is a tough question, normally they give you the equation. So I've actually written the equation. And the reason we need the equation is because we need to see that there's 2 lots of iron oxide, 2 moles of iron oxide, forming 4 moles of iron. And that ratio we're going to use later on. So first job is we've got 240 tons of this chemical. We've got to convert that tons to moles. So I come up to my triangle. We're trying to find moles. Moles is mass divided by the MR. So if I come down to here, there's my mass and there's the MR. The mass is 240. The MR, now again, it's a tough question. You have to calculate this. So we take the formula and we say there are 2 irons and there are 3 oxygens. We've got the atomic mass for oxygen and iron here, so put those numbers in, work it out, and then get a total, and the total is 160. So 160 here is the MR for iron oxide, and that gives me an answer of 1.5 moles. Now what I do is I use this ratio. So the ratio says there's 2 lots of this reacting to form 4 moles of the iron. We've just worked out in the mass we've got 1.5 moles of this. So I'm trying to get from here to here. So I'm going from here to here, which means we are doubling, 2 to 4 is doubling the moles. So I double this and I get an answer of 3. So now I know I've got 3 moles of iron. So my final step, we're going to find the mass. So the mass is MR times moles. So we come down to here, MR times moles. The MR for iron is 56. We're told that in the question. The number of moles we just worked out is 3. So 56 times 3 is 168 tons. Okay, right, the next one, it says aluminium cannot be extracted by heating it. It's oxide with carbon. Aluminium has to be extracted using electrolysis. So if you think what this means, if I have got aluminium oxide and add carbon to it, what I've done in the reactivity series here is I've labelled where carbon is, and carbon is below aluminium. So when these two react together, this means that the carbon is not reactive enough to get the oxygen from this. So this, if it was to happen, would not lead to any reaction taking place. So it doesn't work. So we have to give a reason for this. So we can say that aluminium is more reactive than carbon. So we're telling them that we know that information. This means that carbon cannot reduce the aluminium oxide. So it cannot take away the oxygen from the aluminium oxide. Happy with that one? Predict how we'd get calcium. So calcium in this list is high up. So any of these ones up here, these two, we have to use the process of electrolysis in order to extract those metals from the ores. Okay, so the answer to this one is electrolysis. Okay, in this answer here, we've got a plant that is growing, and it's growing in soil that contains copper ions. So what's going to happen is those copper ions are going to be absorbed through the roots into the body of the plant. So they'll start to be absorbed into the body of the plant. So we then need to get them from the plant. So we'll harvest the plant, we'll burn the plant, and the ash will contain the material, in this case the copper, that we want to extract. Okay, so describe how plants can do this. So what will happen is the plants will absorb the metal ions from the ground, and then we can say the plants can be harvested to produce ash, and then the metal is extracted from the ash that's left. Okay, so there's the steps.